And so our last presentation of the day is from our colleagues at TetraScience, and I think Mike Tarselli is going to present some of the advances TetraScience has made in unlocking insights from experimental data, specifically in power data. So, Mike, on to you.
Thanks, Vin. Thanks, Jamie. Can everybody hear me?
Yeah, you're good.
Excellent, perfect. And let's just try it one click. So let's see, it seems like I've been warned about a delay, so there is a delay. Okay, thank you. I'm just gonna go back up. So let's see, oh, guess I can't go back up. That's fine. I'm Mike Tarselli. I'm the Chief Scientific Officer here at TetraScience. Following Dennis's example, I'll give you a quick background, which is my background is as a synthetic chemist, and then worked in pharma for some time, and then worked at Novartis in information systems, and then at SLAS as a scientific director. So I've now been here at TetraScience nearly a year, and we are excited to show you a little bit about how we are enabling pharmaceutical use cases using our platform. So very briefly, today I'm going to talk to you a little bit about what the Empower Data Science link is, how the data platform harmonizes this data, which is inspired by the Allotrope data model, features and concepts, some data science use cases, and some bidirectional data flow. And I realize now, pardon me, my camera is off. So if you'd like to see me present in real time, this is me. Here I am. All right. So the life sciences data conundrum. We have heard, and many I'm sure have seen statistics, somewhere between 40, 80%. I've even heard higher than this in other references, but the one we like to refer back to is this 2016 piece in Forbes, offering a commentary on data science and data wrangling. And it basically states that somewhere around 60 to 80% of scientists' time is spent data wrangling, i.e. taking data out of source systems that was never intended to be used for data science and converting it somehow, either through text, through JCamp-DX has been said, through a different data format, through Excel, multiple different ways. So we'd of course like to save some of that time, as I'm sure many other people on this call would. So how are we doing this? We are looking at the current map, the current sort of life system, the data ecosystem behind the scenes in pharmaceuticals, and we see it as something ripe for data transformation, right? There are these data sources on the left, scientists, CROs, instrumentation, sensors, informatics applications, and they of course generate data to be consumed. And there's multiple point-to-point streams that connect many of these pieces of source to the target systems that they are meant to distribute to, which of course include ELNs, LIMS, data lakes and warehouses, data science, AI and ML, robotics and control systems, and visualization systems. So again, think in terms of this, things that produce data, things that consume data. And this point-to-point network, and in fact, gated by humans in certain cases, not only as human data wranglers and data buses, but also sometimes in process, right? And the pharma company will say, you know, I really don't want to release these raw results until they've been checked by both a system for validation and also by Jim over in QC. He has to look at these, which of course delays that publication as well and further potentially silos the effort away. So we would like, of course, to look at a new paradigm. And on the Tetra Data platform, which of course is a cloud native R&D data cloud, we see these sources as being collected through our connectors and agents. We see them as being extracted, decorated, and validated. And decorate is perhaps not a concept you hear in file parlance very often, so I'll quickly explain it. Extract means what it sounds like, take it out of one format and into raw data. Decorate, of course, is to append metadata to that particular raw file or files in order to give you a context of where it came from, which instrument generated it, which ELN perhaps recorded the experiment. And validation simply means, did this come off of the instrument or system you believe it did? So you certainly don't want to have 10,000 mass specs coming in and have one NMR FID sneak in there. So then we will harmonize and prepare. Note, we don't say standardize here, we say harmonize to the points made in previous presentations. JSON is the format we are using here to harmonize. So we are using this to create a sort of standard representation of what an instrument data would be. However, it is not itself a data standard. we are also preparing the data for downstream consumption by these systems. And then through data applications, we are exporting the data into the target system that a scientist wants to see it in to take actions on it. In this case, you can also query the data back for using SQL, and you can also use APIs to post to many of these different systems in order to initiate a new experimental cascade. So we like to look at this format, this paradigm of left to right often, but let's not forget that many things are actually kicked off right to left. So if a scientist starts in his or her lab and decides that they want to create a high throughput experiment, perhaps they're going to start actually in a research lab in their ELN or in a production lab in their LIMS system, and they're going to create this sample set list that's going to do something using these instruments. All right, well then we're going to have to support this target to source to target motif, which we now do. All right, so a little further, one more data point for this life sciences conundrum. It's said that 70% of experimental R&D data is chromatography data. And this comes out of a reference on LIMS specification, a book chapter, in fact. And I'll say that the experimental R&D data here, of course, is going to be early data. I'm sure that much of this data downstream in manufacturing, development, and other use cases, perhaps not as high as 70%, but certainly is still a suitably large fraction of the raw data collection. So with that in mind, we're going to look at the Empower Data Science link powered by TetraScience. Empower, obviously from Waters, is a very common chromatography system, that chromatography data system, pardon me, that takes in HPLC, LC data, etc., brings it into Waters through an Empower client. We then have a specific Empower agent we've developed that can lift this, bring it into the Tetra Data Hub, Linux-based, and in order to get it over to our platform. This collection system then brings in through the agent, does the work stream I've talked about previously, and then exports into visualization and analytics software, Jupyter, Tableau, Streamlit, Spotfire, etc. So we're really looking for getting this empowered data into formats such that it can be analyzed downstream and such that you can do more with it. And data harmonization to intermediate data schema, it's probably worth explaining at this point why we're taking this out of the raw, what we're doing with it, and then what the intermediate data schema that we're proposing actually does and is, and what it's not. So intermediate data schema in this context includes two critical components, which is the schema.json, again, JSON-based representation of a raw file format, and a readme.md. So the schema properties, of course, include namespaces so that you can actually fork versions and you can say, all right, I have this version of an IDS, an intermediate data schema, that reads mass spec data from, say, a thermo instrument or a Waters instrument. So then you can take this and you can say, all right, I have this common IDS, but now I want to create a specific use case IDS, or I want to create a specific IDS to another company or firm that wants to use it in a certain way. Great, we can do that using this namespace property. There's a type or a slug, which refers to the type of source system or target system that the information is going to. And there's a versioning. So when we note new things about the system, or the file itself goes through an upgrade, or the system API base gets a refab, great, we can create a new version of our IDS that allows us to upgrade what we can take and intake. And this is inspired, of course, by the Allotrope data model features and concepts. Not only is there the JSON representation of empowered data, and this enables, of course, data science and informatics to work with empowered data downstream, but look at the actual formats that we are taking in down here. Look at the actual particulate nature of it. You are seeing database, project, injection, system, sample, method, result, and channel. These are the common parameters that are defined in the LC-UV allotrope data model. So we are heavily inspired by that model in order to be able to create this format that people can use to harmonize their data. And then again, the data table measures dimensions. You're going to see, my apologies, data cube, also defined in the allotrope data model, can be easily convertible to a tabular format and then therefore queryable by SQL. So you'll see many of the touch points of allotrope data model without it actually being allotrope. And however, this gives a good sticking point for people to use in order to take a harmonized approach to the data and to have it available for building models downstream. And then finally, this two-step representation, this IDS JSON, allows one to create allotrope data downstream using a third-party tool or using self-service pipeline creation. Again, we do not convert allotrope data format currently in TDP in the Tetra Data platform, but of course, you are critically enabled to be able to do so on your own, either in or outside of our platform, using your own logic and tools. Of course, there is the Allotrope Java or C# software development kit, so you can use this on your own time. All right, so data science use cases. Now that you've seen how the IDS works and how the basis of our platform is thought through, let's look at what the Empower Data Science link can do using these core concepts. We're going to look a little bit at what Empower would give you anyway, and the way we have expanded this using a subset of these motifs you see on the left. So we're going to show specifically chromatogram overlay. We're going to show column degradation. We're going to show a little bit about the compliance and a little bit about instrument utilization. So if you are a chromatography expert yourself, or perhaps you support chromatography experts as a data scientist or data curator, et cetera, you've probably seen the Empower system before. You probably realize what it does and its quest to unify data, search data, but it sort of falls short at that point. We will need, of course, some extra systems downstream in order to share dashboards and analytical overlays to drive some improvements for method design. And we would like ideally to surface all of this empowered data in order to maintain compliance. So are we following our internal policies that would allow for a GXP supported process, for example? All right, so let's look at a column degradation example. In this case, we are seeing a spotfire representation of aggregated Empower injection results. And I'm going to draw your attention to these means and these mean clustering results. Here we're looking at 3 separate columns. We'll call them blue, green, and red. And we're looking at their change over time. So the blue and the green actually both start very clustered. These red lines show a 3 standard deviation approach across and away from the mean. So they're clustered around the mean, maybe deviating by 0.5, 1 standard deviation. Perhaps that's probably still within protocol. And you can see a history or a tail of 3 columns as it evolves over a 5-month time span. Clearly, the blue not only having an outlier in March, but also having quite a bit of deviation by the time it gets to May. The red being sort of all over the map and the green as well. So perhaps you, as a chromatographer or as an analytical core facility manager, would have liked to know back when it stopped looking like this beautifully clustered result and a little bit more before it got to drastic so that you might actually lose a production run or a large scale scale up. So perhaps you might want an alert that would tell you, hey, back here in March, this was already unreliable. You probably should have changed out the column at that point. And again, this is not anything fancy. This is supporting the Empower data that you already have through a harmonized representation and then surfacing it into these visualizations. And this is, of course, based on about 20, 30 injections per column, but this could be hundreds or thousands per column, or you could look at multiple columns in these visualizations. Compliance. So you probably have, again, to the previous presenter's points about GXP results, you probably have a protocol that says, all right, let's not permit manual integration of peaks, or let's ensure that everyone has signed off on results. Perhaps let's look at the multiple results of processing. Have you actually reprocessed these? Have you stopped a run? Has something gone wrong that is different than what you would have expected from a normal run on these systems? So we can surface this and we can actually look both in a heat map representation across projects or across runs, and then across a project you can actually go in a how many times did the instance happen. So you can get a general idea of actually the big problem to work on in this particular project is incomplete sign-off. You note that against all of the parameters of the file, you're getting incomplete sign-off in many of these. Perhaps the manual integration, although you might want to pick that out so you don't have to drive a kappa exception, is not the biggest problem in this particular project. But this is something that's often requested from our customers and users because they want an idea on how to enforce their policies internally without perhaps having to go on an experiment cherry picking method. And again, here I'm going to show you very briefly, just in case you are unable to see this sort of smaller text, what each of these subheadings is showing. All right, and chromatogram overlay. Whenever I see this visualization, as a synthetic chemist, I'm actually somewhat blown away because I realize we're only showing 2 peaks here, but I think we've pressure tested this into hundreds or thousands of injections, and you can start seeing real trends emerge, such as baseline correction problems, impurities coming in, retention time issues, asymmetries, in a way you just can't get by printing out 100 sheets and trying to overlay them or trying to do these in a downstream vendor native format. So you actually can see here that you have perfect congruence between these 2 spectra at the 1.25 peak roughly. And by the time you get out past 4 minutes, you're really seeing a lot of drift in this method. Now, of course, you need to retain scientific context. So you need to know perhaps this was a method evaluation. Perhaps somebody was actually showing and widening out the gap or reducing the polar phase to carry this through. Or perhaps this is a symptom of your column going down or a symptom of some incorrect triggering in the injection mechanism. There's many things you could infer here. But certainly, if you are running something simultaneously over and over and over again, you can overlay, for example, 1 entire month's results or 1 entire year's results, and you can start to receive information about how well your column is doing, how well your product is standing up to those conditions, and to optimize your method overall. All right, and then I did promise you something around bidirectional data flow, so let's go into one simpler use case for that. So in this context, we're thinking about where researchers live, right? We want researchers to live where they need to live, which is oftentimes in an ELN or a LIMS system, sometimes even in an MES or an LES if you're going to go even further downstream. We have a connector in the Tetra Data platform that's going to listen for result changes. It's either going to listen for a new experiment to be created or for a new list of samples to be run in a LIMS or a LES. We then have a pipeline in our parlance, which is going to assemble a command. So assemble has to reformat a command to push to our agent. Our Tetra agent, which notably will be the exact same piece of software, which is going to pick up the raws downstream once the processing is done, is going to issue a command to create the sample set method. This is critical. You want to make sure that you as a researcher are not having to actually enter everything in by hand, because then what's the point of automation? Ideally, this is listening for everything that you had started up in your ELN or LIMS, and it's going to carry out that exact process, method, injection times, samples, etc. That loop, once finished, is going to go back up through the exact same Tetra agent as raw. Now, a quick note about raw. We are not just speaking about the vendor binary here. We're speaking about the binary, all processed results, all metadata that comes with it. In our parlance for the platform, we think of raw as anything that comes in prior to our collection step, but is not limited to the binary file. That's going to transit into our cloud through an S3 bucket. A pipeline is going to be engaged to process this raw empowered data to our IDS, our harmonized format. And then again, you as a researcher can use your third-party tools or even outside the platform, run an an IDS to any kind of format extension you wish. So in this context, we're going to convert 2 ELN results. We're going to actually say, okay, push this back into the format the ELN can understand and push it back in. So with that, I think I've helped to show you how the Empower Data Science link powered by TetraScience helps you to do more with an asset that you've already got, how the Allotrope data model has inspired us through its features in order to create our harmonization format, which is intermediate data schema, and how bidirectional data flow between an ELN and a LIMS and Empower can actually have your researchers automate things that they maybe never previously thought about automating, and really helps them to use connection points they've already got without having to restructure full IT networks. With that, I thank the Allotrope organizers, my fellow presenters, and thank you very much for listening and your time.